The enthalpy change that accompanies a reaction is called reaction enthalpy or enthalpy of reaction. The enthalpy change that accompanies a reaction is called reaction enthalpy or enthalpy of reaction. The enthalpy of a reaction is defined as the amount of heat evolved or absorbed in a chemical reaction when the number of moles of the reactants as expressed in the chemical equation have completely reacted. Enthalpy change of a reaction is denoted by delta RH. Enthalpy of a reaction is expressed as the summation of enthalpies of products minus the summation of enthalpies of reactants, where AI and BI are the stoichiometric coefficients of the products and reactants respectively in the balanced chemical equation. For example, the enthalpy changes for the reaction of 1 mole of methane with 2 moles of oxygen forming 1 mole of carbon dioxide and 2 moles of water may be represented as follows. The knowledge of reaction enthalpy helps us in maintaining the conditions required to carry out the industrial chemical reactions at constant temperature. It also helps in calculating the temperature dependence of equilibrium constant. The enthalpy of any reaction depends on the conditions under which it is carried out. Thus, it's difficult to compare the enthalpy reaction value for different reactions. To overcome this problem, the values of delta H for different reactions are expressed at their standard state conditions. The standard enthalpy of a reaction is the enthalpy change accompanying the reaction when all the reactants and products are taken in their standard states. A substance is said to be in a standard state when it is present in its most pure state under a pressure of 1 bar at a specified temperature. In other words, when the enthalpy of a reaction occurs at 1 bar pressure and specified temperature, it is called standard enthalpy. For example, the standard state of liquid ethanol is pure liquid ethanol at 298 Kelvin and 1 bar pressure, and the standard state of solid iron is pure iron at 500 Kelvin and 1 bar pressure. Let us now look at the enthalpy changes during phase transformations. We know that the intermolecular forces in the 3 states of matter are different. Therefore, the amount of energy required to convert matter from one state to another also differs. Standard enthalpy is represented as delta H naught, where the superscript naught indicates the standard state. The process by which matter is converted from one state into another is known as phase change or phase transition. The enthalpy or heat changes accompanying these phase changes are enthalpy of fusion, enthalpy of vaporization, and enthalpy of sublimation. Let's look at each type in detail. Standard enthalpy of fusion is the enthalpy change accompanying the melting of 1 mole of a solid substance in standard state into its liquid state. It is also called as molar enthalpy of fusion and is represented as delta fusion H naught. For example, the amount of heat required to melt 1 mole of ice at 273 Kelvin is 6 kilojoules. Thus, we can say that the molar enthalpy of fusion of ice is plus 6 kilojoules per mole. As the melting of a solid is an endothermic process, all enthalpies of fusion are positive. We know that freezing is the reverse of fusion. Thus, the enthalpy of freezing, also known as enthalpy of solidification, is the same as enthalpy of fusion, except that it has the opposite sign, that is, a negative sign. Now let's look at the enthalpy of vaporization. The amount of heat required to convert 1 mole of a liquid into its vapor state at constant temperature and under standard pressure is called its standard enthalpy of vaporization or molar enthalpy of vaporization. For example, the amount of heat required to convert 1 mole of water into vapor at temperature 373 Kelvin is 40.79 kilojoules. Thus, the molar enthalpy of vaporization of water is plus 40.7 kilojoules per mole. We know that condensation is the opposite of vaporization. Thus, the enthalpy of condensation has the same value as the enthalpy of vaporization, except that it has the opposite sign, that is, the negative sign. Now, let's look at the enthalpy of sublimation. Sublimation is a process in which a solid changes directly into vapor state without any intermediate liquid state. Enthalpy of sublimation is defined as the enthalpy change accompanying the conversion of 1 mole of a solid directly into vapor phase at constant temperature and under standard pressure. For example, the amount of heat required to sublime 1 mole of iodine is 62.4 kilojoules. Thus, we can say that the molar enthalpy of sublimation of iodine is plus 62.4 kilojoule per mole. The magnitude of the enthalpy change in phase transformations depends on the strength of the intermolecular interactions between the molecules in the substance undergoing phase change. For example, it requires about 40.79 kilojoules of energy to vaporize 1 mole of water, while it requires only 29 kilojoules of energy to vaporize 1 mole of acetone. This can be explained in accordance to the fact that the water molecules are held together in the liquid state through hydrogen bonding, while the acetone molecules are held together only through weaker dipole-dipole interactions. Thus, it requires less heat to vaporize 1 mole of acetone than 1 mole of water.